Okay, so we're on to our last example of solving a system of equations with the elimination method. Remember, we had already talked about there's three ways you can get the answer, and we're doing elimination right now. So I want to go over this example for two reasons. First of all, it's an application problem. It's a word problem, something you might actually use in the real world. Second of all, this particular problem is going to illustrate a point that the other two didn't, a higher level question in some way. Okay, so let's look at the question. A business with two locations. So you have a business with two different locations. That's not that uncommon. Okay, by 7 large delivery vans and 5 small delivery vans. I guess I could picture that happening. You have a business in 2 locations, maybe in Lancaster, and you have 7 delivery vans, but 7 large ones and 5 small ones. Sorry, I said so they would have 12 vans. It looks like. And it says location A. Let's put an A by this to help out. Receives 5 large vans and 2 small vans for a total cost of $235,000. Okay, so the first location has 5 large vans and 2 small vans. So I don't know. We could probably write that if we represent the large vans with an X. Some people like to use the L, so I'll use an X this time. 5x and, meaning plus, 2 small vans. I'll use the Y. And the total cost for those vans was $235,000. Well, that's probably very realistic. Okay, location B. This one has 5 large ones and 2 small ones, right? Location B receives 2 large vans and 3 small vans. Doesn't seem like they're getting as much, does it? For a total cost of $1,660,000. Thank you. Got it out. So we have this one would be 2 large plus 3y equals 160,000. Now the question that's being asked is what is the cost of each type of van? So this is this is the money you spent for the vans, and you want to know, well, how much is it if I just want to buy one large van or one small van? How much does each one cost? And from that you could figure out lots of different answers. Okay, so let's figure it out. Now the reason this is an important one to do is because notice that I can't multiply. Well, first of all, I can't just eliminate. They're not opposites. This is a positive 5y. This is not a negative 5y. So I can't just go down. And I can't multiply by any one number without using a fraction to make sure that these would be the same. I mean, I could do a 2.5, I suppose, but there's not one number, a whole number, I can multiply this bottom one by to turn this 2 into a negative 5. And I can't turn this 2 into a negative 3 by multiplying by any one number. So it looks like we're kind of at an impasse here, but that's when we go back to the steps of solving this. And the step said, multiply, if necessary, one or both equations by a constant. So we can't multiply one to fix this, but we can multiply both equations by something to get this working. So, and actually, I find this not to be too challenging because usually it's just the same number that one of the equations have is what you're going to multiply it by. Let me show you what I mean. Let's get rid of the x's this time. It doesn't matter, but I'll just choose the x's. So I'm going to multiply this whole thing by 2 because you see how there's a 2 there? And I'm going to multiply this whole thing by a 5 because there's a 5 here. Now, one of them has to be negative in this case so that they're opposite. Now we just use the distributive property. So 2 times 5, I'm going to write it down here, is 10x. 2 times 2 is 4y. 2 times 235,000, well, 2 times, let's see what that would be. 470,000, sorry. Okay, let's do the bottom equation now. We're going to do the same thing, distribute it. A negative 5 times 2 is a negative 10. That's what we wanted. We wanted them to be opposites so we can eliminate. A negative 5 times 3 would be a negative 15y. A negative 5 times 160,000 would be would that be 800,000, I believe. Let me just double check it real quick. Yeah. And so now we have two equations that have opposite variables, coefficients. So we can just add straight down. These eliminate. 10 take away 10 is 0. 4 take away 15, negative 11. And 470,000 take away 800,000. Basically we can just eliminate all these zeros for right now. We can add them at the end. It's really just saying 47 minus 80. So if you want, you can do 80 minus 47 and just remember that it's a negative. So that would be 33. Now we have to put these zeros back on. Okay, divide both sides by a negative 11. Eleven goes into 33 three times. Oops, excuse me. So y equals. Oops, sorry, this is a negative. Negative divided by a negative is a positive, so it would be a positive 3 and 0. 0, 0, 0. So y equals 30,000. Of course, we found the y. We're not finished. We need to substitute it back in to find the x. And you can choose any number of these equations. You can choose the original equation, the second one, the newly created ones. I'm running out of room on this page. I think I'm just going to try to squeeze it into, let me see if I can squeeze it into this one right here. I will try to fit it in on this page. If not, I guess I could technically just get a new page. But 2x plus 3y, save some room, plus 3 times 30,000 equals I'll just do it like this. This will work. Equals 60,000. Okay, all we do is distribute here. 2x plus 3 times 3 is 9, so 90,000 still equals the same, 160,000. Subtract. Get 70,000. So 2x equals 70,000. Divide both sides by 2, and x equals 35,000. So, what were we able to do from this algebra? Based on that information, we were able to figure out that a small van was 30,000, and a large van was 35,000.